Bismillahirrahmanirrahim. Ladies and gentlemen, Assalamu alaikum. If you're looking at this presentation right now, you have probably already signed up and enrolled at the Institute of Space Technology for the Avionics Engineering program. I congratulate you on making a wise choice. And in this presentation, I'm going to present a brief introduction to the department and also actually in the beginning to avionics engineering itself, because it is not a discipline which is widely available across the universities in the world. So I want to first introduce you to the discipline itself before we talk about the department. So, welcome again to the Department of Avionics Engineering. So, what is avionics? So, avionics is a word derived from the combination of aviation and electronics. It was first used in the USA in the early 1950s and has since gained wide-scale usage and acceptance. So avionics is just not only the electronics in the aircraft, but actually it's the electronic systems that support the whole aviation ecosystem. So we're talking about aircraft, radars, navigation systems that are on board the aircraft, that are on the ground, communication systems, and electromechanical systems, and so on and so forth. All of this is avionics. So, so we describe what avionics is. So what has been, let's say, the role of avionics over the past 2 decades or 3 decades? So I'm just going to read the narration first and then try to explain what this means. A major driver in the development and introduction of avionics systems has been the need to meet the mission requirements with minimum flight crew. In the case of modern civil airliners, this means a crew of two only, primarily the first pilot or captain and the second pilot. This is only made possible by reducing the crew workload by automating the task which used to be carried out by the navigator and the flight engineer. The achievement of safe two-crew operation has very considerable economic benefits for the airline in a highly competitive market with consequent savings of crew salaries, expenses, and training costs, etc., etc. Okay, so in a nutshell, what this means is that, as you know, the amount of sensors, let's say, on an aircraft, and then the amount of systems on an aircraft has been increasing over time. Okay, but during that time, the number of crew has actually been reducing. Although, if you look at all the systems that the pilot has potentially to pay attention to, that have been increasing. And what has made this inversely proportional relationship possible has been avionics, because a lot of the task of what, let's say, the navigator was doing has been taken over by avionics. What the flight engineer was doing, monitoring all the systems and making sure that everything is working fine during the flight, that has been taken over by avionics. If you look at the flight control systems, as the aircraft have been flying through more and more diverse, let's say, dynamic ranges, I mean, in terms of height and altitude and speed, etc., it is becoming more and more difficult for the pilot to be able to control the aircraft, because for reasons of maneuverability, etc., you want the aircraft to be unstable. And an unstable aircraft is very difficult, if not impossible, for the pilot to pilot. Okay, so computers now actually fly the aircraft. It's not just the autopilot, the cruise, the whole the holding the cruise or the altitude, etc. It's actually much more, because disturbances, whatever the aircraft may encounter, there's a computer which monitors all of that and provides corrective movement of the control surfaces, which normally a pilot would do. So there's a computer who's actually flying the aircraft. All of this has been made possible by avionics. The other very important drivers for avionics systems are increased safety, air traffic control, requirements, all-weather operation, reduction in fuel consumption, improved aircraft performance, control handling, and reduction of maintenance costs. Okay, so once you have this automation, of course, the compute if you program the computer properly, and it will be able to function in a more optimal manner than a human operator. Okay. Similarly, here we are talking about air traffic control. Of course, the flies are getting the skies are getting congested, and so you want more aircraft, let's say, per unit area, and avionics is the thing that makes that possible. Right. So, in terms of the cost of avionics in the aircraft, how much of the dollar value of the aircraft is avionics? Well, it depends upon the type of aircraft, but the avionics spent on modern military or civil aircraft can account for about 30% of the total cost of the aircraft. This figure for avionics content is more like 40% in the case of maritime patrol aircraft or anti-submarine aircraft, because they need a lot of electronic gadgetry to be able to detect the submarines. Um, and it goes up to actually 75% of the total cost if you talk about the airborne early warning aircraft, such as the AWACS. All right. So there is a considerable cost in the total cost of the aircraft. There's a considerable percentage of the cost which is avionics. So what kind of jobs do avionics engineers perform? We talked about what avionics is, but what do avionics engineers do? So of course, because you're an engineer, you should be involved in design and development of avionics systems. At least we should prepare you to be able to undertake such tasks. We talk about avionics integration. So on an aircraft, if you want to introduce a new system, you want to install a new radar. How does that talk to the avionics that is already on the aircraft? So the aircraft is a network. It's a real-time but distributed system. Okay, so you have stuff that is talking to each other over a bus. Okay, over a data bus. So that is the job of the avionics integration engineer, so that he's able to integrate new electronic systems or avionic systems and make them talk and function properly with whatever was on board before. Okay. Then we talk about maintenance, repair, and overhaul, and generally called MRO in the aviation lingo. Um, so anybody who's doing, who of course is maintaining the aircraft or repairing them, would need avionics engineers, because, as I said, a major portion of the aircraft is avionics now. Design, development, and communication. Design and develop communication, navigation, and surveillance (CNS) systems supporting air traffic management. As I said, the density of the aircraft per unit area is increasing. So this is the field that will take care of that. And again, avionics engineers are required. And now with our whole urban mobility thing, when you have quadcopters zipping around in the city, that is even more important to have the correct communication, navigation, and surveillance systems. Okay. Design and development of radar systems. Radar has a long history of being associated with aviation because, well, radars were developed to detect aircraft. Okay, so they go, let's say, hand in hand, radar systems and aircraft. So you would normally actually have a compulsory course on radar systems in the Department of Avionics. Okay, design avionics systems for unmanned air systems. Well, again, we're talking about drones, not only quadcopters, but different kinds of drones. They could be fixed wing, they could be rotary wing, or they could be even be airships. Okay, so all of that, now that autonomy has crept into everything, and actually aviation is not immune to that trend. So when you have autonomy, you need better and better avionics systems. Okay, there are engineering functions associated with military aviation. So if somebody's looking for a career in, let's say, the military, the Air Force, then this would be let's say a good qualification to have if you want to pursue a career in that particular domain. So the standard implementation inspectors in aviation, regulatory authorities, well, so in aviation, regulation is paramount. Okay, so everything has to be inspected according to a certain regime, and it has to be made sure that everything works perfectly every time, all the time. Okay, and so of course, when you have inspections of avionics systems, you need avionics engineer to perform said inspections. So, what are the contemporary research areas? So, what are people working on? Well, right now, okay. So, we're looking at advanced avionics architectures. Like I said, it is a network environment. There are different kind of architectures you can use, and whatever benefits that you think that a new architecture can bring in, and you would like to propose that would constitute an area of research. Certification of artificial intelligence for safety critical avionics, integration of UAS in the national. Certification of artificial intelligence for safety critical avionics. So, I mean, everybody's heard of this AI now, so it's taking more and more um, of the mundane, at least, tasks. It's taking over, but you want to be absolutely sure that it does not make the wrong decision. And therefore, for safety critical, and of course, aviation is highly safety critical, you want to be sure that AI does not make the wrong decision, and you need certification for that. And avionics engineers, well, a particular subfield of avionics would be looking at the certification of AI systems. Integration of the unmanned aerial systems in the national airspace. So you have this relatively, up till now, let's say low speed, low altitude, new fleet that has started to fly, and how does that integrate into your wide body aircraft flying over international routes? And when they come into land or take off, there is an interface, and that interface has to be handled correctly, again, for safety reasons. Cognitive pilots for replacing human pilots in commercial aviation. Well, again, we're talking about AI, and as you might have heard recently, actually there was a dogfight between a AI-enabled aircraft and a pilot flying an F-16, and the AI came out on tops. So things are moving pretty rapidly in that direction, and I would not be amiss to say that uh, we're going to say goodbye to pilots maybe in the next 10 to 15 years, and it will be completely automated. So, stealth technologies, don't want to appear on radar. Again, an area that avionics looks into. We talked about the CNS, earlier control, navigation, and surveillance for urban mobility. Of course, spaceborne applications, avionics, which is aboard satellites and rockets and what have you. Design of interactive human-machine interface systems. This is how humans interact with the machine. Okay, so for example, you would have fly-by-wire systems in which uh, whatever load that the control surfaces are experiencing at the moment is not transferred to the human pilot. Okay, so pilots who are trained, let's say who used to be trained on mechanical linkages, they would feel the load of they would feel the aerodynamic loads because they have a mechanical linkage between the control surface and their control column. This is the stick that the aircraft is flown with. When you do not have that, there's a disconnect. When you have a fly-by-wire system, there's no mechanical linkage. It is like motors and these wires which are taking signals to the motors, and they're actuating the control surface. In that case, you do not have a sort of feedback from what is happening outside the aircraft to the pilot. At least you lose some of that feedback. And so you have to design this human interface correctly, then how much movement should be given to the stick. Let's say how much of pressure should the pilot feel, all of that stuff. Of course, there are other haptic systems also, which you will learn about in your, let's say, last year here when we talk about advanced topics. Okay. Simulating aircraft electromagnetic environments, electromagnetic compatibility requirements. Of course, there are a lot of electrical systems that are in close vicinity and they're all operating, and there is a chance of this electromagnetic radiation spilling over from the one to other. So you have to be very, let's say, careful in designing and placing, and there are certain requirements that equipment that goes aboard the aircraft needs to meet. Okay. Again, a domain of avionics engineering. And finally, we have cognitive radios, which means that radios that do not operate on a specific frequency, let's say. So they operate on over a band, and they look for available frequencies in the band and then use particular frequencies so that more radios are able to use the same band. Again, it's the same concept as that air traffic control, but here we are trying to make the optimum use of a frequency band. Now, so I talked about at some length about what avionics is. Now we're going to talk about our particular program. This program was launched in the fall of 2015. It was a part of the Astronautics and Aeronautics, Department of Astronautics and Aeronautics. But this year, alhamdulillah, it has become a full-fledged department. 2 batches have already graduated. The current student strength is about 150. The core specialization areas are flight control systems, avionics system design, radar systems, guidance and navigation systems, and microwave systems for avionics and CNS applications. All right, so the human resource at the department, we have 2 professors, and I'm going to introduce you to the faculty briefly in a short while. There's 1 associate professor, there are 5 assistant professors, and there are 2 lecturers, and there are the teaching and research assistants. Their number is 3. The total faculty is 13. We have some support staff, we have lab assistants, and other supporting clerical staff. There are 2 in that category. All right. So the faculty, this is me. My name is Sohail Akhtar, and I have a PhD from the University of Michigan Ann Arbor in flight dynamics and control. And this is my area of specialty. Then we have Dr. Amin. Dr. Amin has a PhD from the Queen's University in Belfast, and he works on antennas for aeronautical, space, or land applications. Dr. Abdul Wahid, he has a PhD from the Hong Kong University of Science and Technology, and his area is modeling, simulation, and control. Then we have Dr. Zainab, a PhD from Beihang University in China. She specializes in GNSS, Global Navigation Satellite Systems, or GPS, as it is normally called. The signal processing of this GPS, she specializes in this field. Okay. We have Engineer Muhammad Shafiq, and he has an MS from the Nanjing University of Science and Technology, and his area is optical engineering. Engineer Irfan Majid, he has an MS from NUST, and avionics system design and microwave systems. So when you get to your final year, he's the go-to guy. Okay, so avionics system design and microwave systems. He is the guy who teaches this course to all our avionics graduates. Engineer Muhammad Zahid, he has a master's from George Washington University, USA. His area is telecommunications and computer networks. Engineer Sardar Ahmed, MS from NUST, and his area is avionics engineering. So he has an MS in avionics engineering and not in some other relevant field, but avionics engineering itself. So Engineer Lal Said is a lecturer. He has an MS from IST, and he specializes in signal and image processing. Again, lecturer Adil Yusuf, MS from IST in Islamabad, and again, signal and image processing. We have Engineer Hamail Sultan, MS from IST Islamabad, and her area of specialization is wireless communications. Anila Ali Ahmed, MS from ComSats, and her area of specialization is control. Engineer Shifa Nadeem, MS from IST Islamabad, area is wireless communication. All right, so let's talk about the laboratories. So I said that this is electronics for the aviation ecosystem. So a lot of laboratories we are going to be sharing with the electrical engineering department, some with the aero department, because we are like at the interface of aeronautics or aerospace engineering and electrical engineering. So what you see is that you have, I'm showing here some labs which are shared. Okay, these will be shared with electrical engineering, let's say, and then there are 3 labs that are specific to um, avionics engineering, which are radar systems and avionics system design. All right. And these are just some pictures from these labs. But of course, when you come here and you will visit and you'll be shown around the labs. So the Avionics Department Coordinators, the TRA and RAs and lecturers that I showed you, apart from their teaching assignments, they're also doing very important administrative work, which is the coordination of the training activities at the Department of Avionics Engineering. And each of them has been assigned a different category of this coordination work. MS Anila Ali Ahmed is the academic coordinator. Okay, she has the bulk of all the training activity. She coordinates. Okay, so you will have when you come to the department frequent interaction with Miss Anila Ali Ahmed. Ms. Humayun Sultan is a quality coordinator. She makes sure that whatever processes we are doing, they are according to some quality criterion. Okay, and then she also deals with our accreditation with the Pakistan Engineering Council. Ms. Shifa Nadeem is the training coordinator, but here in training, what we mean is not the teaching that is going on, but the training that we do in terms of short courses, let's say, okay, for external participants, also for the participants of IST itself. Lecturer Lal Said is in charge of final year projects. Okay, so in the final year, you have a lot of interaction with Lal Said, and he's also the sports coordinator. So he will organize the sports for our teams, etc., for our department. Lecturer Adil Yusuf is the research coordinator. Okay, so all the research activities, if you are when you go to your senior years and you want to write papers, etc., then you will have some interaction with Adil Yusuf, and if he's still around by that time, because he's about to embark on his PhD, and we wish him well. But there was somebody who will be doing this particular job. Okay, and apart from that, if you are looking at, let's say, funding that we are trying to get from different agencies, then he's our coordinator for that, also keeping track of what funds were allotted and how are they being used and so on and so forth. Okay, there is a mentorship program at IST. Every student is assigned an academic advisor from the faculty who holds regular meetings with the students and can be approached anytime for consultation and advice. So each of you will get a mentor. Okay, now, how should you study when you get to IST? Okay, so first of all, evaluations are carried out throughout the semester, and you cannot rely on your final exams. Of course, the semester system is now prevalent in almost all universities in Pakistan, and how is it different from what you've been doing before is that mostly the results earlier were determined by the final exam, in the board ka final exam. That is what determines the result, right? But here in the semester system, everything you do during the semester counts towards your final grade. So you have to be on your toes all the time. You have to read up and keep up with the pace of the class. Okay, that's what the second bullet says. Stay regular. Stay regular. That's excellent advice. Stay regular. Okay. Visit your instructors for clarity on what you have not understood in the class. This is not a huge department. We have just one section that we induct every year. So the instructors are available to you. You can go discuss with them if you have not been able to understand. Normally, we would also set aside a certain class, which is called which we known as office hours. So the instructor will tell you that I will be available in my office from this to this time for this particular class, and you can go and discuss whatever academic issues that you are having. Do not rely on class notes, lecture slides alone. We're not saying do not rely on them completely, just do not rely on them alone, okay? So you have to develop a habit of reading your textbook. Okay, the kind of questions that you will be examined on will not be only restricted to what you were taught, but there might be certain extensions of that. We want people to think and extend what the knowledge that have learned in the class. We want to extend that further. Okay, so you will have certain questions will be in that domain. So if you read up, if you have a broader view of things, then you're in a better position to get good grades. And finally, there will be zero, and I mean absolutely zero tolerance for unfair means. Okay, we pride ourselves in being honest and fair, and we want our students also to be honest and fair and do the best that they can do, but never take a shortcut. Okay, and this box at the bottom, it just says that genius is 1% inspiration and 99% perspiration, or another way I could say is that your I will is much more important than your IQ, because I have seen people with very high IQs doing poorly because they're not interested in putting in the hard work. So if you put in the hard work, you will, inshallah, come out with flying colors. Okay, some of the e-learning resources that are available to you. First of all, since it's going to be online, at least for the first month, and hopefully as the COVID has started to dissipate, and hopefully it will go away altogether, we'll come back to our regular teaching method. But your online classes, we will be teaching over something called MS Teams, and you will be informed about how to use it. Okay. So online education, especially for the freshmen, is something that you will have to get used to pretty quickly. All students have access to IEEE Explore Digital Library. This is the Institute of Electrical and Electronic Engineer, USA. It has a huge repository of all the work. It archives all the research that has been done over the years in this particular field. So you have access to it. You have a large data bank of ebooks in the ISD library. A number of computer labs with internet access are available. Of course, there's campus-wide Wi-Fi, and it is available to all the students. Pakistan, so internship opportunities for avionics students. You might be aware, you might not be, but let me just inform you that internship is absolutely mandatory for all graduating engineers. All right. So we have our arrangements for this internship with the Pakistan Aeronautical Complex, Camera, Pakistan Air Force, PIA, other civil aviation agencies, the National Institute of Electronics, Aeronautical Design and Development Organizations, and Electronic Design and Development Organizations. These are certain organizations, they are in the private sector, in the public sector also. And finally, so what can you expect when you graduate? So if you're looking for a job, all right, these are the organizations that can offer you jobs. And of course, if you want to be an entrepreneur and start up something on your own, that is actually the best thing to do. But then the sky's the limit, all right? But if you're looking for a job, these are the organizations that can offer you. Thank you very much. I hope I have been able to convey a sense of what avionics is and what the avionics department is to you in this short presentation. And I will take live question and answers in our orientation session. Thank you very much.